Hey, what is up, guys? Welcome to Software Engineering channel. This is Karthik. This is another video in this multi-part video series. In these videos, I'm building a network library from the scratch. As I'm programming, I'm explaining some of the reason behind the decisions that I'm making. What is the design principle that is backing those decisions? I'm explaining as I'm programming. So if you have not got a chance to check out my previous video, I highly recommend it because this video and subsequent videos are not going to make any sense if you have not watched my previous videos, or at least check out the code from my GitHub repository. I'm going to link. I'm going to add a link to that repository in the video description. Check out that and get yourself familiarized with the code base at least. Otherwise, this video is not going to make any sense. All right. So what are we gonna do in this today's video? So far, we have implemented is sending a request, receiving a response, error handling, all those. There is one thing that I wanted to do in this video to talk about URL request. How do we generate them? What are the ways we can just facilitate generating the URL request? When we think about URL request generation, it doesn't sound like a big deal, right? So what is a big deal? Because the consumer of this library, they can just generate, instantiate a URL request, right? URL request, and then just, send that, use the send method. They can just send that method to us so that we can handle it. This sounds like a very trivial thing to, create a video. But let me talk a little bit about well, it works, some degree that is true because it works. But in this video, I'm gonna show what are the complications that could involve in a real world project, or at least I have seen in my past work. What are the difficulties that we were facing, right? So let's talk about a URL request, the origin of URL request itself, right? Usually in a project, the projects are going to be divided into core models and feature models. It's two basic categories. So the core models involves, independently working or like a single purpose single purpose libraries. These libraries are, for some of the examples, are like network library, that is one core model. Another example could be like a logging library. Another example could be session library. Things like that, right? So another example could be UI libraries. We could just we can go ahead and then list all these core libraries. But anyway, these three is a good example. But feature models are like, feed is one feature model. If you're writing, if you have a, if your app have a feed or something, or settings is another feature model. What a user profile is another feature model. What other thing? I don't know, things like that, right? So this feature model is the one that they are going to start any network calls, because the feature model is where the features are where the user is going to interact. So maybe you'll have a view model or something in your code. This view model will have a, like for example, feed view model. This view model will have a function called fetch feed. So inside this fetch feed, you're gonna have a you're gonna create a URL request with URL, blah blah blah, right? HTTP or HTTPS, whatnot. You get the idea. So then we're gonna say network service. Let's send it. So this is how we're gonna do. So in between, we're gonna configure what are the probably we're gonna configure body is equal to something request dot, I don't know, probably I think it is add value to it, add value, add header value or something like that, right? I forget the API anyway, but you guys get the idea. Header for HTTP header or something like that, right? So we're gonna add a header. Whatever. So these are all the things that we're gonna do. This sounds like very straightforward. Then why do we even have to talk about uh, request method as well? Something like that. So then this seems like pretty straightforward. Why are we even talking about this thing in a video? So I'm gonna give you some examples in the past that I had faced in my previous companies, previous works. So all these items that we are adding here, these are all feature specific input for the URL request. So let's list out in a feature model, we're gonna have a URL, maybe method, HTTP method, and HTTP header. So this is feature specific. Majority of the time we will not be doing it, but if in case you have some requirements that you wanted to do, requirement to add a extra HTTP header, you're going to do that, and HTTP body. Probably that's it. Like usually these are all the things that the URL, sorry, these are all the things that any feature module would send, create, or just add, whatever that is. So but let me give you more, right? So in the past I had to add something called a session token along with the HTTP library, along with the HTTP request. If user is logged in, then we're gonna have to add session token. If the user is not logged in, then we're not gonna add session token. That's how it is. So next thing, maybe we're gonna add a device information for a backend. In the backend side, we're gonna log which device is making the call, what are the device type. They're gonna have a couple of analytics on their end. They're gonna need this information from you. Probably you need a user's language preference. That is from you. What other thing? Maybe you have a web view that you have opened. Sometimes in the past I have had to open a web view. So this web view will give, for the web view we have to send a HTTP cookie while we are initializing WK web view, or sometimes we're going to obtain some cookies from them. So we're going to refresh that cookie, and then sometimes we need to send this cookie along with our URL request. What are the things that we may need? So the thing's good, right? Device information. So let's stop it here, right? So let's stop it here. We may need to add additional information. Also, when it comes to token, we have three use cases, right? One, no token for pre-authentication, token after post-authentication. Number three, new token after token renewal, right? So this could go even further. Sometimes you need to obtain a new token to provide extra permission to extra access to certain features, certain tasks in your app. In the past I have had worked in a feature that I have worked in a company that they will initially give you a token, but in order to access um, additional areas in the app, you have to promote the token, because basically it's just a sort of a giving you extra permission, because your user is not authorized to access those specific pages or screens in the app. If you wanted to do that, you need to promote your token, so that in that case you're going to receive a new token. So these kind of things goes on and on and on and on again. Sorry, these kind of thing, it just the complexity of token, it just increase if we talk about user registration token. then for now, just let's leave it this way, just for a simple purpose. So you see all this information that needs to be appended along with the URL request, right? So this is what I'm talking about. This is the reason why I wanted to talk about URL request in a single video. So if, for example, we ask our feature model to add all these items over here while they're sending a request, this is going to be a this is going to be this is going to create a duplication in our code base. So this is just a one URL, one endpoint that we're calling in this fetch feed method. Imagine how many API calls that we have to make in our code, how many features that we will have. Each feature will have a number of endpoint. Each endpoint will need to add all this information. So then the code is going to be redundant. In that case, then we need to figure out a way to automatically add all this, add the below, right? We need a mechanism to automatically add all this thing in our code base. And also we need, so if that is the case, then we need to have an entity or a class, something like that. For now, let's just say class default tokens, right? Sorry, default headers, or default request information. Right? All right, so let's just say we have a class called this, and then we have a default request information. But if you notice that if this is the case, then the default request information, it has to handle this token renewal logic, pre-authentication and post-authentication logic as well. And then when we wanted to have a device information, they need to maintain, they need to work with a UI kit or UI device, or maybe UI device is just a one single place where we want to obtain the data, but maybe there could be some other business logic involved in it to process the device information. Maybe we want to hide some information, we want to show some information, things like that. So that is another complication there. So the user preference wise, let's think about it, right? So when user launch the application, we're gonna obtain the user's language preference from our local device, right? Device will have always a preference. We can just obtain this information from local.current object. But then once user logged in, user may have in the app or the product may maintain their own user preference, like a internal user preference in their settings. They may have their own settings page where user can go change their language preference or a local anything. So in that case, we're gonna have to update the user language preference again, correct? So this it complicates the logic as well, and cookies as well. So cookies has to be updated, maintained. See, if we add all this information under a one single class, then the one single class is going to grow. This class is clearly violates the single responsibility principle, because as you see, as I have mentioned, it is maintaining, it's doing multiple things. So then in that case, maybe if we say, hey, if that is the case, then our obvious thing is obvious way to decouple, split this thing is just create a separate class for everything. Session, I don't know, session information. Let's call it session information for now. Maybe class device information. Locale information, URL request information. key URL request information, right? So if you split that, then everything becomes a single responsibility. Then we can supply this. We have to then we have to find a way to supply this information to the to our network service so that it can make use of this information to generate a URL request, right? So if we divide this way, then if you notice that what's going on, yeah. So if you notice that the first four thing that we have listed, these are all feature specific feature concern feature concerns, right? These are all feature concerns. These are going to be automatically added, right? So then the feature model can only worry about the things that they wanted to add the HTTP request, that are those are feature specific. Then we have to figure out a way to automatically add all this thing. So that's what we're gonna see how best we can do in our network library, right? So that's what this video is all about. Hopefully this explanation is good enough. Let's see how best we can do. I'm gonna move this thing down. Let's write a given this information, let's write a use case, right? Okay. Given a network service, when a URL, when a request is received, then the request, then I don't know what do we call this? We need to name this one. I wanted to name this process something. What do we call it? I don't know. Then the request, yeah, I'm going to call it canonicalizing this request. Or, then or instead of calling a technical term, why don't we just, use a simple English word? When a request is received, then additional information for info is added to the request before it's sent to the server. All right, that's what we wanted to literally do. So when we receive a request, we want to add this additional information. Additional information is added. We wanted to add the additional information to the request before we send the request to the server. So if that is the case, okay, let's see what we have here. So you see we have a network service. This network service receives a anytime we call anytime when a consumers send a request, this is the place where it is going to end up. So this place, we're sending this request to the platform class, which is going to be URL session. We are abstracting the URL session with this network platform. If you're watching this video first, so we have something called network platform. This abstracts the URL request. So this way we can mark this URL request in our test. So that's the way it is. So we're going to send this request to the platform and then asking it to execute. So before we send this request to the platform, we wanted to write a logic somewhere over here, something like request bar new request is equal to current request I'm just not writing. I'm just brainstorming here. I'm not writing a test right now. So I'm just showing this to help you guys understand where we may need to look into, because if you watch this video without my previous video, so if you watch this video before watching my previous video, this will not make any sense. That's the reason why I'm just writing some pseudocode here and there to help you understand. So this is the new request. This is place where we wanted to add additional information. add info to this request, and then send this new request to the um, request for execution. This is what we wanted to do, in an essence. All right, so as usual, we have a test. We wanted to write a test first. Let's see, function test, give one, let me copy this. Given a network service, when a, you know what, I have a something like this. I wanted to write it here. All right. Given a network service, when a request is received, then additional information or info is added before the request is sent to server, right? Simple. So we want to add additional information. Okay, let's see. Let's copy paste our existing test, because this is one of the thing that since we are using helper, since we are using public API all the time, we can just copy paste our previous test and then make use of it instead of typing all the time. All right, let's just say we remove all the unnecessary information there. We have a request. Okay. Okay, so this is what we have. We're having a URL, we're creating a request, and then we're sending a request to the service. Since the send method is going to provide us with the publisher, then we're going to have to start the publisher. This is the utility method that's going to call the sync operation. That's a nice utility method. Anyway, so now since it is a unit test, we have a platform that is mock platform. This mock platform is going to store any request that it is receiving. I'm going to open this side-by-side window for you guys to check how the actual production code works. You see, this is a mock. Why did I just close this? Right. So on the right side, we have our production code that actually calls the URL sessions data task, because we are just confirming this network platform to a URL session. So on the test, on the other hand, we're not doing that. Instead, we're just mocking the URL session, because that's what we wanted to mark. Once we send the request to URL session, from there onwards, it is not under our control. So that is one end of boundary. So we need to mark that in our test. That's what we're doing here. So while we are mocking it, we're just storing the recent request that is received, so that we can make use of that in our test, right? Oh, this instrumentation test. All right. So that's what we're doing. So when we send a request, the mock platform is going to store the recent request. Then we can just, check what is inside. So now let's say we're talking about the additional information, right? So let's, for example, say let's take this guy, URL session information. So let's say we have an entity. That entity is going to provide us a URL session related information for the URL session. Sorry, URL request. URL session info. I don't know. Let's name this one session token provider. All right, session token provider. So this token provider may have a class. Let's, you know what, instead of writing this, let's talk a little bit about how let's work on our test first, and then just see how that works. So I'm going to look for a session token ID, and I'm going to say let token is equal to UUID. We're going to have some temporary token. So this is the token I'm looking for. So when I send a request, I'm going to check if the header X session ID is automatically added or not, right? So that's what I wanted to check. So let's just build this app and then run. Oh, so this throws. No, it's never used. Come on. All right, it's running. Testing, obviously it's going to fail because we have not done anything um, to include this session token automatically, right? So now we're gonna do, what we're gonna do is that we're gonna work to pass this test. That's what that's what the test driven development goes. How do we do that? So now the consumers are, this is the, if this is what the consumers are going to use, then we need to find a way to provide all this the information providers. We need to provide all this information providers to our network service. So in our network service, the network service needs to know what are all the information that it needs to append, right? So let's look at our examples here, right? We have a URL session, we have a device information, local, HTTP token, so HTTP cookie, things like that. But these are all very specific. These names are very specific. But the thing is, if we say, hey, if we directly add this thing over here like this, that token provider, we can add this thing here like this, token provider or device info provider. Provider, something like that, right? We can add n number of things as the requirement comes, as the requirement changes. But this thing is not good, because if a requirement changes, or if in case we wanted to add new information to our request, then I'm going to be directly editing this network service, or at least I'm going to be directly editing this network library, right? So that violates this open close principle. That means that our library that we are building is not extendable. So it just, we have to modify it. That's, as I said, it's violate open close principle. We need to build our library in a way that it is open for extension, at the same time it is closed for uh, for modification, right? If that is the case, then we wanted to abstract this guy instead of naming them specifically. Maybe we can just call it URL request information provider, or info provider. Let's call it providing, maybe it's a protocol. Providers, right? So what if we just call it a array? What if I declare a protocol called call your session information provider? So this guy is going to provide information. Since it is an abstract, we cannot just declare a session. If we declare a session, then we are again making this protocol specific to certain information. we don't want the network library to know anything about session or the device information or a token or a user language or nothing. We don't want anything. We don't want the network library to know any of this thing. So we need to be abstract. Again, that is one of our goal. So all our public APIs, it has to be abstract. So that is another one of our goal. So if that is the case, then what I'm going to do here is that I could just write a function that say, hey, take this request and then provide a new request and modified request. Okay, request append, you know what, add is better, append, add info to request. And then it's going to expect a URL request in return. So if this is the case, then what we can, in the consumer side, what we can do is we can just, you know, we can have this guy over here in the consumer side. So this code, I'm going to delete it, but I'm just going to show, if you add this way, then the consumer can just confirm this protocol. And then this protocol obviously have one method. Then we can just, you know, request var new request equal to request dot add value to token token, right? X session token. Session ID, and return the new request. So in the consumer side, we can do something like this. So now this is really abstract. So we can add n number of this thing here. Maybe we can have one more thing called a device info URL session information, and then just, you know, do that. And we can just supply this thing, the array of information providers over here. So that way our network library is abstract, and from the consumer side, they can work with the different libraries. Because see, here's the thing, right? If consumer wanted to obtain a session information, they need to work with the session library, right? So if the consumer wanted to work with the device information, they need to work with UIKit library, right? Because UI device have some information, UI device object have that information, and so on, right? Oh, why am I adding a hash? Yeah. So things like that, right? So they can work with them, but anyway, so it is the concern of the consumers, not the concern of the network library. So I'm going to do something like this. So if that is the case, let's move this protocol to an API, because we have an API group. I'm going to add this person here. I wish Xcode, you know, automatically does that. Even after all this year, they're just making us do this thing. Anyway, add info to request, URL request. Okay, that is fine. So now, if you watched my previous video, or if you check out the code, you will see that this network service is not going to be directly instantiated by the consumer. The consumers are, since it is an internal class, they cannot obviously have access to the init method. So we have something called builder. We are using a builder pattern to create a service, and we are sending the network requesting protocol to the consumer. So that is how the consumers are going to interface with our network library. If this is the case, then we can declare here for providers. We can, you know, info providers, maybe we can just have a different name, but you know, the info provider seems like, you know, well understood at this point after all this explanation. Maybe we can just come up with a better name. Okay. So I'm gonna supply when consumer calls this build method, we're gonna create a new network service and then send it over to them. So now we can have this. Let's see what's going on. Oh, extra argument in the call. So that means okay, we don't have that, eh? Why don't we copy this one and then put it out there? All right. Oh, no public. Okay. So now we have this thing. Let's build and see how that works. We have another error. So it is a test error, which is not a problem. Let me check if it is recording. Yeah, okay, it is recording. Anyway, all right. So let's come here. In our send method, we are in a network service now. So in our send method, let's call this information provider one after another, and then obtain a new updated request. So for that to happen, so this is since this request is an immutable, then I'm going to create a new request, final request. All right, request. So this way I can mutate this one. So I'm going to send this final request to the platform class. So in between, I'm going to write a for loop, info provider. Oh, nice. Oh, Xcode 13 have really good auto completion. I really like it. Final request is equal to info provider dot add info to this final request, right? So iteratively there we're going to add so that we don't lose the previous information. Anyway, all right. So now we are iteratively adding all the information to the request. We're preparing this request and then we're just, finally sending this request. Okay, so this one is good. Oh, wait. Oh, okay. Right. So because previously we were, so if you notice that, so this method is expecting a publisher to be returned from it. Previously, we were not writing this return method because in Swift, if you have only one statement in the method, the return is implicit. If you have more than one statement, then you have to explicitly specify the return. So now we have to write the return. Let's build this thing. Hopefully this works. Okay, this is failing. That is due to our test failing. Okay, that is because, okay, so in our test, we have to provide the same information as well. So now, for now, I'm gonna send a empty array. Let's see if this builds. Oh, build succeed. Um, Wait a minute. This cannot be. Okay, so this also should fail. For some reason, it is not also failing. What's going on here? And we build. We're building that, right? Unit test, analyze, build, run. Oh wait. Yeah. Okay. Let's take this. Okay, so now let's see. Okay, now it's building, so no problem at all. What's going on? Why it is not showing now? I messed up something probably. Let me clean it. Let me build for testing. Okay, anyway, it's not showing the colors, but anyway, it should be fine. So now let's run our test to see how this is reacting. Okay, everything is paused except this one. Correct. Obviously, this is not going to be green. That is because we are not supplying any session session information. So let's come to the mock and then create a mock session provider, right? Uh, Wait a minute. Mock session provider. I'm gonna call this class. You know what? We don't have to call it mock session provider, is enough. Okay. All right, so import our, we have to import it, import our network. URL info providing. Okay, URL request information providing. Okay. I don't know, for some reason it's the colors are not shown now. Did I messed up something like that? Something. Okay. Previously it was like this. I'm gonna leave it like this. Okay, come on, Xcode. Show me some colors here. Anyway, something's wrong with the Xcode. Anyway, autocomplete is always like this. They don't show the colors at all. So then, even after all this year, guys, I'm surprised that Xcode is still behaving like this. Anyway, all right, whatever. Let's say token key. Let's say guard let token unwrap it key is equal to header key. If nothing, if this information does not exist, return the receiving request. Otherwise, create a new request because the request is immutable. What if we just have this thing as a in out, so that they don't have to create a new what did we call it, a in out, but anyway, let's keep the thing as it is. New request dot add. I'm going to add this token. You know what? Let's call it a value or token, whatever. Yeah, whatever. Return the new request. All right, so now we have our mock session provider is ready. Let's build this thing and then see. Okay, it's building. So now this is the information that we're going to supply in our test. So since in our test, in our setup method, we're sending an empty provider. So what I'm going to do here is I'm going to create a session provider. Then I'm going to say, I'm going to instantiate the session provider. Oh, now the colors are showing up. I wonder if the colors are showing up somewhere. Oh, yeah, no. Public APIs are screwed up. Anyway. All right, so we have this guy, and then we're going to send this person over here. So now we have a session provider. Cool. So before we start the test, I'm going to configure all this session provider. Session header key. I'm going to look for this key. Session dot token is equal to token. All right. So what I'm doing here is that, okay, before we send the request, I'm telling the session provider when a token is asked, use this token and then this token key, so that in our test we can just verify it. All right, sounds good. So now we're sending the request. Then in our header field, we are going to be expecting this token, right? You know what? Okay, token. Yeah, we are going to be expecting this token. Correct. If this token exists, then our test is success. Nice, right? So yeah, so we are marking this session token. So we're just sending the token session, sending the request, and we are testing if the session token is automatically added in our header fields. Good. That is fine, but you know what? Let me verify it one more time. Let me add one more providers. You know what? Instead of calling the session provider, why don't I just never mind. I thought I could just use a one single file, but no. device info provider. I'm going to add another thing called device info provider to make sure that all the providers are working. Sorry, meaning I'm going to add one more provider called device information provider. So that way I can verify that our network service is iterating through all the providers and then appending all the information. Device info provider, all right? I'm going to call it device type. Header key is fine. Okay. So this guy is going to provide a device type. That is fine. So let's instantiate our device info provider here. Info provider. Come on. And send this thing along with other one. Okay. So why don't we just declare this guy over there so that it is accessible. Var person wrapped, which we know that it's going to be instantiated. Okay, sounds good. So we have our info provider ready, and then we're sending that info provider as well, device info provider as well, to the network service. So in our test, let's modify this one a little bit more. Type it's gonna be iPhone 12. Okay. Device type header key. Okay. So not the session provider, device information provider. Okay, right. Okay, sounds good. So we have two information providers. These two information has to be available in our final request. It contain device type, key, and device type. Okay, they should contain both. What's gonna? Oh, we're not able to find it. What is it? Network? Okay, yeah, network. I forgot the name of the library itself already. Nice. Okay, so all our device information providers are iterated, and then the information is added to the header field. This is working fine, right? So now the consumer, on the consumer end, they can just work with multiple libraries, session libraries, UIKit, or cookies or whatnot. They can just work with the different libraries to create this device information provider and then supply that information provider to our network library, right? So if you notice that, so you see, let me open this thing in a side by side. See, one of the things that I mentioned in while we are analyzing this is that this session is a lazy information, correct? So it will not be immediately available. Pre-login, we will not have a token, and then the post-login, we will have token. And if the token is renewed, we make it a new token or the same token, it doesn't matter. But anyway, so these are all the information, right? So if the consumers create this session provider, like actual session provider in a production code, what they can do is, oh sorry, something's going on. So what they can do is they can just work with this again guys, pseudocode. They can work with the session library maybe they will have a part session, okay, session info, session update, info updater, and then they can just get the session from there, right? So if that is the case, then if the session is available, we're gonna, so this is the concern of a session library. So if the session is available, we're gonna update in the session token. If not, this is going to return the same URL request that it receives. If there is a new token available, obviously the session info updater is going to have. The session info updater just again is pseudo kind of logic. In the production code, this is how we may need to do. Yeah, so the production code, they can just supply all this information to us. But as far as the network library is concerned, so this network library is still abstract, right? So let's delete all this guy. Okay, so that's how we implement. That's how at least I implement a URL session generation. So this way, I get to keep my library as abstract as possible. I'm not depending on any external library. At the same time, my library is the network library is extensible. At the same time, it is closed for any modification, which clearly adheres to um, open close principle. Open close principle is again is a part of a stable abstraction principle as well. So I highly recommend you guys read something about the stable abstraction principle as well. So now comes the code coverage analysis. Let's run this code one more time. Okay, it's testing. Okay, it's success. Test is success. Let's go to the code coverage. Previously, we had 100% code coverage. Where is the network? Okay, there you go. So we still have 100% code coverage, right? You see 100% code coverage for the network library. Yeah, right. So we are strictly writing a code. We're strictly writing a production code only to pass the test, and the test are satisfying a use case. So we are actually writing a code to satisfy a use case, and we are covering all the edge cases. Our execution is reaching all the corners of our code, production code. So 100%, 100 everywhere. That's it. There you guys. There you have it, guys. So that's how I write URL request generation. So I will add this code. I'm going to push this code in our in the same GitHub repository. Please check out that, and I will see you guys in the next video. Thank you. Thank you for watching.